Hello, in this video we want to see how to apply differentiation to find the tangent line and the equation of the normal. We will further look at a practical question on definite integrals. So this problem is applied in both high school mathematics and even those who are in the university. Our first question says, find the equation of the normal to the curve. So the curve is given by y is equal to x squared minus x plus 4 at the point -1, 6. So let's visualize this. So this is our curve. All right, now a tangent is just a straight line that touches a point on the curve, and a normal line is a line that is perpendicular to the tangent. So perpendicular, we mean they cross or they meet each other at 90 degrees. So the blue line labeled T is the tangent, and the red line labeled N is the normal. All right, so first of all, how do you find the equation of the tangent? One, you need the gradient of that tangent, and then you need a point at which the tangent passes. So we will need the gradient at this point, -1, 6, okay, and then we will need this same point, -1, 6. So how do we find the gradient? We will find the gradient by taking the derivative of this function. So remember the derivative of y, which is denoted as dy dx, okay? We are just saying change in y divided by change in x, and we read this as dy dx. So this derivative is just the gradient of the line at this point. So I want you to remember that if we have y is equal to, say, x power n, then the derivative of y with respect to x is just the same as. So with the differentiation, you drop the n, and then you reduce the n by 1. Reduce the power by 1. So what is the derivative of this function? So x squared minus x plus 4. So we said we drop the power, so we write 2x, reduce the power by 1, we remain with 1, then minus. So x is power 1, so we drop the 1, it will be 1, then x, 1 minus 1, the power is 0. So any number to the power 0, it's 1. So the derivative of any variable is 1. Now, the derivative of a constant is 0. So the derivative of this function is 2x minus 1. Now, what is the value of this derivative? So we are going to evaluate this function at -1 because the x coordinate here is 1. So this is just the same as 2 multiplied by 1 minus 1, and this is -2 minus 1, which is -3. So the gradient of the tangent line is -3. Now let us go further to find the equation of the tangent. So remember, the equation of a straight line is given by y minus y1 is equal to m. So we will call m as m1, representing the gradient of the tangent. Then we say x minus x1. So where our point x1 is -1 and y1 is +6. This is y minus 6 is equal to, so m1 is -3, then x minus, so this is x minus 1, okay, minus, so this is -1, it will be +1. Okay, so we can just make y subject and say If you want, you can expand this further, which is negative 3. If we expand this, we have, this is just an extra work if you want to know how to find the equation of the tangent. But our question requires the equation of the normal. Okay, so having found the gradient of the tangent, which is negative 3, we will find the gradient of the normal. So remember, if you have perpendicular lines, lines that cross each other at 90 degrees, then the product of their gradient is equal to negative 1. So if m1 is the gradient of the tangent, then m2 is the gradient of the normal. Their product is equal to negative 1. So m1 is negative 3 multiplied by m2 is equal to negative 1. If you divide throughout by negative 3, you find that m2 is equal to 1 over 3. So using the equation line, y minus y1 is equal to m x minus x1. So we have y is equal to y minus, in this case we have already been given our y coordinate is 6, so we have 6 is equal to m, our m2 is 1 over 3, then x minus x1 is minus 1, so this will be plus 1. Close. So this is wonderful. So if you have reached this far in watching this video, hit in the comment section and tell us where you are watching us from. This is a definite integral from negative 1 to 1, then 1 minus 4x plus 3x squared with respect to x. So this integral has a form integral from a to b f of x, where f of x is just this function with respect to x, and this is given by, so this capital F is the antiderivative fx minus f of a. So f of a, f of b is the upper limit and f of a is the lower limit. So our task here is to find the antiderivative. Now let me give you a hint here. So I'll say hint. Okay, so if f of x is equal to x power say power n, then the antiderivative capital F of x, which is just the integral of this guy with respect to x, integral of this with respect to x, is just the same as, we are going to say x, we are going to add 1 to the power and divide by the new power. So we add 1 to the exponent and divide the function with the new exponent. All right, so our task now is to find this guy. So let us go ahead and find the antiderivative. So remember, this is the sum of terms, right? This is the integral of sum of terms, which is just the same as the sum of integral of terms. So what is the first term? So the first term is 1, which can be written as x to the power 0. So you know that any number to the power 0 is 1. So we want to find the antiderivative. So the antiderivative of this, of x to the power 0, we said it is x 0 plus 1 divided by 0 plus what? Plus 1. So this is just the same as x power 1. So the antiderivative of 1 is x, okay? The next one is 4x. So if you already know how to do differentiation, you don't need to go through this process. You can just fast forward and watch how we put in the limits. Okay. So what is this? So the variable here is x. So we said 4. So x, it is to the power 1. So we add 1. So 1 plus 1, it will be power 2. The new exponent is 2, so we divide this thing by 2. So therefore, the antiderivative would be is 2 into 4, it's 2. So it will be equal to 2x squared. So this is the antiderivative of the middle one. Okay. Now, what about the last one? So the last one is 3x squared. So we said, how is this going to be if we find the antiderivative? So the antiderivative means 3, okay? So x to the power 2, so 2 plus 1 is 3, divided by the new exponent is 3, so divided by 3. So 3 and 3 cancels. So this is equal to x power 3. So we have x, 2x squared, and x power 3. So meaning that our capital F, okay, our capital F, meaning that our capital F, the antiderivative, okay, so I'll just write our antiderivative of negative 1 to 1 of 1 minus 4x plus 3x squared with respect to x is just the same as we said the antiderivative of 1 is x minus the antiderivative of 4x is what? 2x squared. Then plus the antiderivative of 3x squared is x squared. Okay. So I will write in this form and put negative 1 and 1 on top. Okay. But what does this mean? So remember, what is inside here is our f of x. So remember we said the integral of f of x, little x from a to b dx is just same as capital F evaluated at b, which is the upper limit, minus the capital F evaluated at the lower limit. So let us go ahead and evaluate our f at the lower limit. So I will write capital F of 1, which is our upper limit. So where there is x, we put 1 minus 2, 1 to the power 2 plus 1 to the power 3. Actually, this is supposed to be 3. Okay, so what is this? This is 1 minus 2 plus 1, which is equal to 0. The upper limit is giving us 0. Now, what is f of negative 1? So f of negative 1 is just the same as negative 1 minus 2 negative 1 squared plus negative 1 power 3. So what is this? This is just same as negative 1 minus 2, because negative 1 squared is positive 1. So negative 1 power 3 is negative 1. So this is negative 1 minus 2 minus 1 is equal to negative 4. Okay, but we said we need to do f of 1 minus f of negative 1. So this is just the same as 0 minus 4, which is equal to 4. So therefore, our question, the integral from negative 1 to 1 of this function is equal to 4. Thank you for watching. Like and share for more content.